Good afternoon, I'm here on day one of Embedded World 2024 and joining me here today is Stefan Berggren, Senior Product Marketing Manager, and Erik, Carlberg, Senior Product Manager of u-blox. And today we're going to be discussing wireless MCUs. But before we go into that, maybe you could give us an introduction into u-blox.
Sure. So u-blox, we are a Swiss semiconductor company. We have the head office in Carlberg outside Zurich. We help customers to reliably locate and connect things that we do in automotive, professional, as well as consumer markets. And we do that with locating things, that is via GNSS, chips, SIPs, and modules. And the cellular, the communications, we also provide for low category LTE.
Right.
And then for short-range radio, that is Bluetooth and Wi-Fi modules.
Okay, well, jumping into it, can you provide an overview of what constitutes a wireless MCU and its significance in modern IoT applications?
Right, yeah. So wireless MCU is a several module that contains not only a processor with memory and peripheral interfaces, but also a radio that you can use in IoT. So that could be a Wi-Fi or Bluetooth radio, but the great thing is that you have both the MCU that can control your system as well as the radio in the same package.
Okay. All right. And what trends are shaping the wireless MCU market today, particularly in terms of CPU performance, multi-radio capabilities, and security enhancements?
Yeah, well, we see that it's growing every year, so to say. The specifications are increasing. The MCUs becomes more powerful. It used to be maybe a Cortex M0 MCU, now then moved to M4, and now it's M33. And maybe it's not just one MCU core; it could be multiple, making the system much more capable. Also, the memory is increasing because of the applications are becoming more and more complex, needing more memory. And finally, on security, there are new standards coming out on security, and these wireless MCUs, they are actually following that trend. So they are adding more and more security functionality, making them really good options for applications where for both security, processing, as well as radio communication is required.
Okay, fantastic. And how do the NORA-B1 and IRIS-W1 series align with the current market demands for higher performance and security in wireless MCUs?
So I would say that the NORA-B1, that's more or less double the capacity that we have had on previous generations from Bluetooth LE modules. So doubling the CPU performance, doubling the memory, as well as doubling the clocking frequency. So capacity is really increasing a lot. So that we also see in a number of applications that have that need. We have a lot of discussions on Matter, and where you have a need for both processing power, security that Erik talked about, as well as not much memory. So that is very, very well into that. The IRIS module is even more powerful, so having more CPU performance compared to the NORA-B1 as well. And also the same type of security. So that also fills into, for instance, the Matter context where we have big need for memory, processing power, as well as security. That are some of the applications.
Okay, and could you explain the primary design philosophy behind the NORA-B1 series, particularly the role of its open CPU architecture?
Right. So with the NORA-B1, we wanted to have a really capable wireless MCU, but in the same time in a small form factor. So what we did was that we could reuse the form factor that we had, which is before the NORA form factor, which is a 10 by 14 millimeter. But we could also include that together with the radio and the MCU, a very well-performing antenna. And the MCU has its dual-core Cortex M33, which actually lets the radio have one core, while your application is then free to use the other core. That means there are less conflict. You can make sure that your application performs as you want it to do without having any restrictions from the radio side of things.
Okay, and what unique features does the IRIS-W1 series offer, especially in the realm of Wi-Fi 6 and Bluetooth Low Energy modules?
Right. So the IRIS-W1 is a Wi-Fi 6 module, as you say, and it's also dual band. So it supports both 2.4 and 5 gigahertz bands, which we see is has been very important. And then on the Bluetooth side, it's so of course Bluetooth LE, the version 5.3, which is the latest one available. And on top of that, it actually has support for Thread as well. So it's a triple radio, Wi-Fi, Bluetooth, and Thread. So it's a tri-radio in this Iris form factor. So that's something that we are very, very happy about, and we're really looking forward to see that hit into market now.
Okay, great. And back to the NORA. So the NORA-B1 and the IRIS-W1 series catered to the diverse needs of consumers, automotive and industrial markets. How do they do this?
So first of all, I mean, the NORA-B1, that is what we call qualified for professional usage. So it's meeting the qualification for industrial harsh use cases. So it's not meeting the requirement for automotive. It's not automotive ready. So it can't be in the first mount applications in automotive. So that we have other modules from u-blox. However, it can be used in aftermarket for automotive aftermarket. Could be ODB dongles, could be insurance boxes, could be tachographs, etc. So it's aftermount solutions. Fits very well. But then it's for industrial grade type of application. It could be for industrial automation, could be for building automation. And then as we are a positioning company, it fits very well into asset tracking and tracking things, containers, pallets, etc. And then, of course, it can be useful for consumer applications as well. So I talked before about smart home and Matter, it goes there. Fits very well into those. It could be for pet tracking and those type of applications as well. So I would say it's a versatile module that fits into many different applications.
Okay. Well, with the evolving standards in wireless communication, how do your modules address the need for high speed and reliable connectivity?
I think it's, and when it comes to higher data speeds, then we have our portfolio of host-based modules that better fit into those applications. So there we're adding higher order modulations, we're adding larger bandwidth, larger channels, also to increase, and also higher data interfaces. So data throughput is important in those segments. I would say for wireless MCU, it's more IoT type of applications where data throughput is not that important. So it's more about reliability, and Erik talked about Wi-Fi 6 to be able to have many different clients in the network. So that is well suited to Wi-Fi 6. It's also keeping the channel for longer time. I mean, in industrial automation is really harsh, so there a longer range is important, and that also counts with the Wi-Fi 6. I think that is also a good thing that is IRIS is supporting. Yeah, so I think rather focus on reliability and longer range and those use cases. Also mesh, I forgot about that. I mean, that you can connect node to node in order to prolong the distance.
Okay, great. Can you discuss the developmental ecosystem around clipboards and how it accelerates IoT project deployments using your modules?
Right, yeah. Actually, I brought some examples here. So both with NORA-B1 and the IRIS-W1, we have developed our evaluation boards having these sockets for clipboards. And clipboard, that's essentially coming from a company called MicroE, and they have these boards which you then easily can slide in, click into to this EVK, like that, right? And then in this case, I've added, so we have a Bluetooth module here, I added cellular connectivity, like that. And there are more than 1,500 of these clip cores, different variants. It could be a display, could be a satellite positioning module, it could be cellular, it could be LoRa, it could be an accelerometer or whatnot. So there's like endless of opportunities, and you simply just click them in, and our EVKs are supporting these. So it's a way of quickly building your prototype, making sure, testing your application, doing a proof of concept before maybe you kick off your projects and then make the real investments. So this is an easy way to get started.
Oh, fantastic. What challenges did u-blox face in combining Wi-Fi 6 and Bluetooth Low Energy in the IRIS-W1 series, and how were these overcome?
Right. So with Iris, we really wanted to go to Wi-Fi 6 because, as Stefan explained, is a very important technology for industrial use cases. But we also wanted to make sure to have 5 gigahertz support, dual band supporting Wi-Fi, because we see that in 2.4 gigahertz, it's very crowded. You can see it here in this fair. It's hard to get a connection. So in some environments, you simply don't get service on 2.4 gigahertz. So we wanted to have dual band Wi-Fi together with a powerful MCU. And that was kind of hard to find those chipsets actually in the market. But since u-blox, we're gold partner of NXP, and they had their RW612 chipset, which we were able to get started with early and develop the Iris module around that. So that's the story.
Okay, fantastic. In terms of integration and deployment, what advantages do the NORA-B1 and IRIS-W1 series offer engineers and developers?
Well, in the module, we just don't only put the chipset on a PCB, but we do full qualification and certification of the module. So whenever you put that module into your end product, you can leverage the certification work we have done, which means that your time to market is much shorter. Your project investments are much lower because you don't need to go to the lab and do all the costly RF measurements. But then, of course, we have integrated antennas into our module. So that means that you don't need to be an RF expert or radio expert to get a good performance. So those are things that we provide with our monitors.
Okay.
But also one aspect there is that we also have our form factor policy. So it's we keep the same form factor in between families and technologies. So that makes it also easier for a customer that have one module already using one technology to quickly migrate to another technology or another module, keeping the same form factor and keeping the same pinning.
Yeah, you're absolutely right. I mean, here we have a NORA-B1, which is a Bluetooth module, but we also have a version that's called NORA-W1, which is then Wi-Fi. We have NORA-W2 with another flavor of Wi-Fi, and NORA-W3 with yet another flavor. So the story goes on. The NORA remains the same, but the different technologies that comes in the package.
Okay, well, fantastic. How does u-blox support developers in leveraging the full capabilities of the NORA-B1 series? Open CPU for custom application developments?
Yeah. So with NORA-B1, we actually developed this kit, which we call Explore IoT 1. I mean, it's a full-fledged prototyping kit. It actually contains more or less everything you need for IoT. I can open it up here. We're gonna see on the inside. We actually have the NORA-B1 module there, which is the main CPU of this system. So, and then with this, we have a set of software applications that are open source. Customers can take them, they can try them out. It's typical IoT use cases like sending sensor data to a cloud service. It could be also using doing positioning. Like there is a GPS GNSS satellite receiver.
Okay.
There is a cellular module. The kit comes with trial license for our cloud service. So it's actually the 3 months of free data usage with this kit. There was also Wi-Fi. So all of this, we support both hardware. The hardware design is open source. The software designs are open source. So that makes it easier for the customer to kind of hit the ground running.
Wow. So now moving on to sustainability, of course, a big topic in this industry. I wanted to see, how does u-blox approach environmental considerations in the design and manufacturing areas?
Yeah, so sustainability is of course very important for u-blox, and we even have it in our vision statement. So the future with us is precise, smart, and sustainable. And that is a little bit, also that we are targeting applications that are good for sustainability. So with our GNSS, we're optimizing route to reduce the amount of energy that is needed for transportation, or the gas that is needed for transportations, and also indoor position that have more smarter routes in the factory and so on. So we're leverage on that to make a smarter solution. But when it comes to direct, our own development, so we are measuring both, our direct or direct impact and indirect impact, and we did a threshold in 2022, and now we are set in 2025 we should reduce that with 10-20%.
Right.
Until 2030 we have 50%, and then being neutral in 2040. So that is what we can achieve from u-blox perspective. Then we are a fabless company, so we rely very much on our partners, and so we're working very tightly together with them also when it comes to environmental issues and so on also, so that we are following. And specifically for the modules that we're using now with IRIS and the NORA, they are produced in Flextronics in Austria, and they also have ISO 14001 certificate. So yeah, important for us, of course.
Okay, and what future developments can we expect from u-blox in terms of wireless MCU technology, especially building on the success of the NORA-B1 and the IRIS-W1 series?
Yeah, I think that it will continue to evolve when it comes to CPU performance and so on, and memory and so on. So that trend will continue, and so that's for sure. Security in IT is always important, so there we'll also see improvements or enhancements. Iris, we talked about being dual band. Of course, we're also addressing the 6 gigahertz band to further reduce the congestion in the network, to offer more channels and reduce the risk of congested networks. So that of course important. And then always cost is important, so more meat for lower costs. So so that will of course also continue. Yeah, I think. Do you think of anything else?
No, I think that's pretty much somewhere else. Yeah.
A lot to look forward to.
Absolutely. Yeah.
Okay. How do you touched on security, so I wanted to say, how do embedded security features in your modules ensure the protection of data in IoT applications?
Yeah, well, we've always carefully selected the components to be secure. So we're working a lot with our chipset partners to get the most secure hardware as possible. Essentially, it starts, for example, with in a module like NORA, there is secure boot functionality. That means that the module will only start up if there is an authenticated software on it. So if there is a rogue software, it will not start up, right? And then the memories in the module, they can be encrypted. So you can, if you have your passwords or your certificates, they can be stored encrypted, right? And then of course, the modules support encrypted data communication, TLS communication. We've been pioneering that. We argue on these small modules, so we're having support for the latest TLS standard, making sure that the encryption is very secure. And then, of course, when you connect to a network, there are different authentication methods, like like WPA3, which we support in our Wi-Fi modules. There's also Wi-Fi W or the WPA Enterprise, where you have more sophisticated methods to authenticate you against the network. So all those things we work actively, we both with our hardware, but also in the software that we deliver with the module.
Okay, fantastic. Can you highlight any successful implementations or case studies in either the NORA-B1 or the IRIS-W1 series where it's been effectively utilized?
I think, what you showed here is a very good example with the Explorer kit. That we're using a lot, and I'm sending out to customers and so on that to test our technologies and all the technologies coming from u-blox. I think that is a very successful application of the NORA series here. So for sure. Then I think NORA family goes into medical type of applications. Then that is a strong segment for us. Getting asset tracking I was talking about before, that is of course a very strong segment for u-blox that we try to conquer with our product propositions. And then I think NORA-B1 in general fits very well as a sensor. So you have them in edge computing and even machine learning already running on the sensor itself. And so that could be for industrial automation and building automations. So, but again, it's a versatile product.
With the IRIS, you do mention Matter before. IRIS is such a powerful module. It's a powerful MCU. The wireless MCU there is very powerful, a lot of memory. That makes it perfect for Matter gateway. So being the gateway between maybe a Fred network and a Wi-Fi network, then IRIS can be there in between and do that translation. So we have some of those projects that are running already.
Okay, fantastic.
We actually also seen IRIS popular in appliances. And they are looking into, first of all, being dual band. They have often the microwave oven in the kitchens that is deserving the 2.4, so that is one aspect. But also the energy declaration of appliances is really tough. So when they need to make sure that they are so power efficient as possible, even on the connectivity, so then also they're asking for Wi-Fi 6. Therefore, Wi-Fi IRIS fits very well into those type of applications as well.
All right, fantastic. What are the target areas for the NORA-B1 series? I know we've spent a lot of time talking about them, but maybe if we could just run through a couple of them.
I think
how its features optimized for it.
Well, I think we mentioned medical. So medical is an area where security is of great importance. See, the NORA-B1 has a lot of security built in. In the MCU, there is what is called the trust zone, which is essentially an area in the MCU which is protected. So there you can run sensitive code, and that's important for many medical customers. Now, so that's one example. And then you have some of these. I know as well.
Yeah, and the NORA-B1 also act as a Matter node, node, Thread node. So it's low power consumption and supporting Thread as well as Bluetooth. So.
Yes. And then it's having enough memory, because Matter tend to be a bit memory hungry, but NORA-B1 has enough memory to support those use cases as well.
Okay, fantastic. I would ask, what are you demonstrating at your booth? Of course, it being Embedded World. You talked a lot about Matter. So regarding Matter and the applications of on Wi-Fi and Fred wireless MCUs, including RW1, what's being demonstrated?
They actually show a complete Matter network in our booth, so that's really pretty cool. And in a very small form factor as well, so I can easily handle it, manage it in the luggage. Yeah, so there we're showing the complete system. So we have one Thread end node, so that is some typical for battery-operated devices. So that is using a NINA-B5 module. Then we also have the translation between Thread and Wi-Fi. So that's something called the Matter border router, gateway or border router. Then we have one module called MIRIS-W1. Then we have the wireless access point as well, so JODW3, as well as then Matter Wi-Fi endpoint. So we're showing all the different nodes in the Matter system. So and the application, it's a Lightning application, very simple. But we wanted to show that we have all the modules that you need in order to implement all the different device categories or network types in the Matter network. So that is one demonstration. Then we'll also do a demonstration on access control. So there we're using a technology called the Bluetooth direction finding. So basically we have a tag sending out the advertising signal to an anchor board, and that is what's showing that here. So it's an ANSI 11 anchor board is called. So that actually calculates how the signal comes into and it calculates the angle, and that is through a phase difference between the antenna elements on this antenna board. So there were two antenna boards, and by that you can calculate the position of the tag, and you can then simulate that when you're approaching, for instance, the door opens. So that we show at the booth live, and it's a pretty good accuracy. So I mean down to half a meter accuracy. So it's pretty cool, and it created actually a lot of interest in our booth already. So
well, I can see why. It sounds very interesting. How did u-blox perceive the evolution of wireless MCU technology and its impact on IoT and emerging markets?
Well, we see that there will be more and more of wireless MCUs. They will be more capable. We've seen that already, as I explained before, coming from kind of a low capable MCU, moving up the chain, and more memory, higher clock frequencies. And I think for IoT, this has great significance because it's very often you have size constraints, you have cost constraints, but by combining the MCU with the radio, you will get a more efficient solution. And it takes less size. It's easier to integrate. You reduce your time to market because you have everything in one package, and so you can essentially center all your development, your system around this wireless MCU. So I think that's some great significance for IoT.
Okay, excellent. And in a market with crowded with innovative solutions, what distinct advantages does u-blox offer through its wireless MCU products?
First of all, I think, as we mentioned before, the form factor policy, it's easy to migrate from one NORA to another because they look the same, they have the same dimensions, they have the same pinout. Secondly, we do embed antennas, and obviously in a radio, an antenna is a very important piece, but it's not that easy to get it good all the time. You need to have special expertise. So that we've spent a lot of time on our antennas, making sure that they are performing equally well in all directions. Because that's another thing with these devices, the end devices, you don't know in which direction you will need to radiate. But having an antenna that radiates equally well in all directions, that's a great benefit. And what else can you do? I mean, we see the form factor is small, so the NORA is 10 by 40 millimeters, so it's barely noticeable. We have even smaller Bluetooth modules that are 6.5 by 6.5 millimeters, so they are actually often they're smaller than doing a chip design because we can access more expensive fine pitch technology in the module because they are so small. So you can use that on a small scale, but not on a big scale maybe. So those are some things that we're working with.
All right, and finally, what can you tell us about your partnership with DigiKey and what implications it have for your customers?
I mean, obviously, DigiKey is a great partner for us. We have all our modules available. We have all our evaluation kits. We have the Explore IoT kit. We have other similar Explore kits available. So we're a very happy partner with DigiKey, and we always try to make sure that the first place that our modules is available is on DigiKey, right? So our customers can get them there. as soon as possible. So at this show, we're part of the you have a lottery here of some kind where we can win development boards. So if you're really lucky, you will get a u-blox development board out of that. So those are some things that we're doing.
Well, with that being said, Erik, Stefan, thank you very much for joining us today. It's been great.
Thank you. Thank you.